Okay guys, welcome to our AP Calculus review on pre-response questions. So this is problem number 3 on day 3 of our review. Victor, can you read the problem for me please?
John rides his bike along a straight path. John's velocity can be modeled by Vt equals t minus 2e squared t. In meters per minute for 0 is less than t, less than 10 minutes.
Okay, so question A says find the V prime. Now V is velocity already, right? So V prime, that means it's acceleration, and the unit used right here is, if velocity has a unit of meters per minute, so V prime should be meters per minute or meters per minute square. Okay, take note that acceleration is square. So to solve for this, so I'll just write letter A right here, solution. Now in this case, this is calculator active guys. So you're gonna use calculator for this. So we have V prime of 4. V prime of 4 is approximately, so use calculator now. It should be math 8, right? So you're gonna have and then change this t into x. Calculator doesn't have variable t, but instead just change that into x. So x minus 2 and then e to the power of square root of x. Okay, and this is to be evaluated at 4. X is equal to 4. So what is B prime of 4 now? Anybody has the answer? Go to math 8. Okay. Yes, Jenny?
11.084.
Okay, 11. So V prime of 4 is approximately 11.084. And what is the unit? So we have meters per minute square, and that's the unit. Okay, now we should be careful with the unit. If it says, because the problem says using correct units, and then are we done for the problem? We are not, because the next is explain the meaning of V prime of 4 in the context of this problem. So how we explain now? So at t equals 4, the time. So this is now the justification. At t is equal to 4. For what? Is it minutes? Yes or no? So 4 minutes. So need you to write the 1. So t is equal to 4 minutes. John's acceleration. This is now acceleration, right? V prime is acceleration. So is 11.084 meters per minute per minute. So that's how we explain. So at t equals 4 minutes, Jan's acceleration is 11.084 meters per minute, or we say per minute square, because it's already an acceleration. Okay, any question on problem A? To find the velocity, the acceleration of the velocity. To find the derivative of the velocity. So the derivative of velocity is acceleration. Okay. Next, Samantha, can you read problem B for me, please? Okay, so is Jan's speeding up or slowing down now? What is speeding up and slowing down? Anybody who could recall? So I'll just do letter B right here. So what is speeding up? If velocity and acceleration. Very good. So if velocity and acceleration have the same sign, so that is speeding up. How about slowing down? If velocity and acceleration have opposite signs, okay? So one is positive and one is negative. Or if both are negative, so same sign, right? Velocity and acceleration, so that is speeding up. Or if velocity is positive and also acceleration is positive, then we can say that it is also speeding up because they have the same sign. So, we have velocity t minus 2 and then e to the square root of t. Now, let us say velocity, let's take the velocity as 1. Okay? So, v1 implies that this is 1 minus 2 times e to the square root of 1. Okay, so negative 1 times e to the, what is the square root of 1? Still 1, right? So power of 1. Therefore, this is, what is e to the power of 1? What is the value of e? 2 point. Can you press the calculator? It's going to be approximately 2.7182. Am I right, guys? Okay, so we have now negative. So V1 is negative 2.7182. So this is for the velocity. And how about acceleration? So AT, the acceleration. Or can I just use blue color because the black color is not good enough this time. So for acceleration, I'll use blue color, blue marker. So AT is equal to v prime of t. So at is equal to t minus 2 times e to the square root of t. And we have to do at a is equal to 1, or t rather is equal to 1. So to be evaluated at t is equal to 1. So can you use calculator to take the derivative? We're gonna have to imply that this is x minus 2 d dx, and then e to the power of square root of x. And what is that? What is acceleration? So use calculator, do math 8. Anybody has the answer for the acceleration? What you have, Exeter? 1.359. Okay, question. They have the same sign. The velocity is negative while acceleration is positive. So what is our interpretation now? Slowing down. So who is slowing down? John or Roy? John. Okay. Is slowing down. Because, what's the reason? Because VT and AT, so V1 and V prime of 1, V prime of 1 is acceleration, right? Have, what do they have?
Different sides.
Have opposite signs. Very good. So have opposite signs. Can I move this a little bit so I can have question C, or can I have question C right here, continue, and then right on this screen, question D. So for question C. Okay. Gian, can you read question C for me, please?
Roy is also riding a bike along a straight path. Values of Roy's position, st in meters, are given in the table as selected time. Use the data in the table to approximate Roy's velocity at time t equals 4 minutes.
Okay, so it says right here, velocity at time t is equal to 4. Now, based on this table, guys, based on this table, we only have 0, 3, 5, 6, 8, and 10 minutes, right? Is 4 minutes in the table, yes or no? No. So how we do that? Take the, what did you say a while ago? So we do V4 is approximately S prime of 4. Okay? And what is that? Approximately, we have S of 5 minus S of 3. You get me? S of 5 minus S of 3 over 5 minus 3. Okay? So we take the average, guys. So what is S of 5? Anybody? What is S of 5? Okay, very good. 48. 48. How about S of 3? Dalia, what is S of 3? Okay, so 10. 48 minus 10 over 5 minus 3 is 2. So, this is going to be 38 over 2. Or, we say 19, right? Am I right, guys? 19. And what's the unit right here? Meters per minute. This is just a velocity, right? So meters per minute. Okay, so moving on to question D. It says, based on the information, who is going faster at t is equal to 4? At time 4 minutes. Who is going faster? Is it John or Roy? So how we do that? So we take the velocity of John and also the velocity of Roy. So I have for John right here. Can I use red color for John? So VT at what time? At t is equal to 4. Okay? So implies 4 minus 2 e to the power of square root of 4. Am I right, guys? T is 4. So square root of 4. So implies that this is 2e, and then square root of 4 is 2. So 2 times e to the power of 2. So what is now John's velocity at time is equal to 4? Calculator, please. 2 times e squared. So V4. What is the velocity of John? Anybody? Say it loud. 14.778. This is the velocity of John. So what's the unit? Meters per minute. This is velocity. So meters per minute. Okay, How about Roy? What is the velocity of Roy? At V4. What's the velocity? 19 meters per minute. So, 19 meters per minute. Okay. Question. Who is going faster? At time is equal to 4 minutes. At 4 minutes, who is going faster? Is it John or Roy? Based on this data. Roy. So, how we write now? It appears Roy is going faster. So, any question, guys? Sorry, it appears. I miss S. Sorry for that. So it appears that Roy is going faster.